Hello everyone and welcome back to the Winter Data Meetup. I hope you all are enjoying the insightful talks and discussions we had so far. Meet Naveen, lead data engineer, who will take you on an exciting journey in the world of Databricks, a cutting-edge platform for big data analytics. Join him as he delves into Databricks architecture and its seamless integration with Spark, unlocking the full potential of DataLake and DeltaLake technologies. Get ready to explore the immersive world of Databricks and discover how it's revolutionizing data management and analysis. Now, before we dive into our next session, I'd like to take a moment to ask you for your support in helping us grow our community and recognize the speakers. Firstly, if you enjoyed the content we are providing and want to stay updated on future events and talks, please consider hitting the like and subscribe buttons below this video. Now, for something a bit special, in the video description below you will find a link to the talk page where you can provide your feedback for this talk, give speaker a badge, and rate the session if you like or if you don't like it. Through the session, if you have any burning questions or insights you'd like to share with us, don't hesitate to type them into the chat box in YouTube or a community platform. Our team will be monitoring the chat closely and will collect all the questions to discuss with the speaker after the presentation. Now, ladies and gentlemen, let's welcome our speaker to share his valuable insights about Databricks with us. Naveen, floor is yours.
Thank you so much, and hello everyone. Welcome to the session. So, topic for today's session is comprehensive exploration of Databricks. Here we will talk about the starting from basics of Databricks, what Databricks is, what benefit it provide, how the architecture looks like, and then we'll deep dive and we'll also have a demo at the end. So let's get started. And so before starting, let me introduce myself. I'm Naveen Nagar. I have 13 plus years of IT experience in mainly in data analytics domain. I have like collaborated with various clients from different sector, either telecom, healthcare, energy, and helped them in uh, designing and implementing data solution with cloud technology, with Databricks, with data warehousing solutions. So that's about me. uh, let's s- let's see what is the agenda for today. So we'll start with very basic, what is Databricks. We'll introduce Databricks. We'll also have a quick overview. If you are new to Spark, we'll also have a quick overview, what is Spark and how they are related, Databricks and Spark. We'll go through Databricks key feature, how Databricks provide ability to create a cluster or spin up the cluster. We'll also see this with a short demo. We'll go deeper into Databricks architecture. We'll also understand how Delta Lake is the new terminology that you see, and how what was the problem that you have in Data Lake, which is solved by Delta Lake and Lakehouse architecture. And we'll also see all the feature provided by Delta Lake, and we'll end this session with a demo. I'll show you all the features of Delta Lake, how you perform it, how it's available for you, and then we'll go with all the questions that you have for us. So let's get started. So let's start with a very basic, what is Databricks. And if you see this diagram, so the core of the Databricks, or the center of the Databricks, is Apache Spark. Spark is like widely used distributed computing processing engine. It has been used widely with all the big data processing. It has been used widely, like before Databricks also many companies are have been using this Apache Spark for all the big data processing basically. uh, Databricks is a different data and AI company, which again like founded by creator of Apache Spark only. But Databricks is a separate company basically, which allow us, or which provide us to a platform where you can work with a Spark in a cloud environment. So Databricks is a kind of, you can say, a multi-cloud platform where you can work with Apache Spark. It's available for all three cloud as of today. So it works with Databricks, works with Amazon Web Service. Databricks work with Microsoft Azure. It also works with Google Cloud. So Databricks has an integration with all three cloud. We can say like it all the integration has been might be different, because for Microsoft we can say it is a deeper integration, because Microsoft Azure provide Databricks as a first line service. I mean, when you create Databricks service from Microsoft or like Azure take all the responsibility or provide you first line of support in term of like how you manage your Databricks. But it's available with all three cloud, and yeah, that's how Databricks has evolved through time, that you get a single platform to work with Apache Spark. As we are talking about Apache Spark, so let's have a quick overview if you are new to Apache Spark. So Apache Spark is distributed computing processing engine. It has been used widely, as I mentioned, like it has been used widely by many organization. You talk about like Netflix, Yahoo, they all use Apache Spark to basically distribute, like process their large scale data. They perform large scale data processing with Apache Spark, which is like sitting on thousand of nodes, petabytes of data they handle with Apache Spark. And if we go back to time, like Apache Spark basically was developed to overcome some of the challenges that we used to get with Hadoop or MapReduce kind of platform. So initially, like when we work with Hadoop and MapReduce, there was it was like complex to write some program in Hadoop or in MapReduce. Hadoop was like not suitable for like interactive computing. It was also like very slow in term of performance. It was like very complex to write those programs in MapReduce. So Spark basically overcome some of the challenges, and that's how like Spark has been evolved and replaced this MapReduce paradigm. And many companies now, for all the big data projects, they have been using Spark. Spark provide like set of high level API in term of data frame, data sets. So you basically work with like data frame where although like you are working in a distributed environment, but you'll feel like you're working with a table, with a row and column structure only. And everything is abstracted from you, where all the distribution, all the distributed processing will happen behind the scene, but you will be directly working with data frame API. And Spark provide, like if you see this architecture also, like Spark provide a better Spark SQL engine which optimize your query whatever you are going to perform. And that's how like you perform all the operations with the Spark. So that's very quick about Spark. And the reason like I'm talking about Spark, so Spark has been widely used, but now again the question is if we already have a Spark, then why Databricks? So to work with the Spark, definitely like we have to do manage everything by our own. So we have to create a cluster. Cluster, like we have to create a cluster where you can work, where you can basically perform your computation. You have to manage all the securities related to cluster, related to your environment. You want to write a Spark program, then you need a kind of a third party tool where you basically write all this code. So all the things you have to manage. But this Databricks basically, and that's how like Databricks come into picture. Databricks is your work when you work with Spark. So it basically provide you a platform, a single platform. It provide you the ability to create a cluster within a few clicks. You can create a cluster, you can configure your cluster, you can provide what kind of a driver you need, how many how much memory you need for driver, what should be the load, depend on like if you're from data engineering, if you're from machine learning, depend on your workload, you can decide what kind of cluster you want. Database give you kind of a Jupyter kind of a notebook, where environment where you can within a single click you can start writing a notebook. You don't need any third party tool, where you can start writing your Python, Scala, Java, Scala, R or SQL code into notebook. You get administration control, you get all the options for your machine learning workload. uh, Databricks also provide like database and tables in form with help of high meta store. And when you work with Databricks, you also get optimized version of Spark. So there are many optimization performed by Databricks, and when they provide you a Spark environment, they provide you optimized version of Spark, and you get the benefit when you work with Databricks. So That is the reason we like Databricks is helpful for us when we are implementing large scale data processing. uh, Little bit on Databricks cluster. So as we have been talking about like Databricks cluster, we can create a cluster. Cluster in short like is a collection of different virtual machine that work in a distributed environment. So Databricks offer you two type of cluster. One is like all purpose, one is job cluster. um, all purpose is something like when you want to perform some interactive workload, or you want to perform some ad hoc analysis, so you create this cluster manually with some configuration. You provide all the configuration that you need, and this cluster will be available for you. When you want to you, if you want to stop it, you can stop. You want to restart it, you can restart. But this cluster is going to be available. You can share with your team. Like this can be shared with multiple members, and that's how all purpose cluster you can create. If you are working in automated workload kind of environment, then you will go with job cluster. And when you start your job, the cluster will be created with some computation power. Your calculation or your computation will happen, and at the end when job finishes, this cluster will be terminated. So you can't access this cluster outside of your job. So depend on the workload, you will choose like you'll need all purpose or you'll need a job cluster, and accordingly you can decide and you can create your cluster. Now I'll show you like how you create a cluster in Databricks environment. So uh, this is the Databricks home page, we can say. There is an option like you just click on compute. Compute is nothing but your computational power, or you can say like a place where you can create a cluster. So from here you see like there are types like all purpose, job compute, and there is another type called pool, but we mainly talk about all purpose and job compute. Here you can create, just click on create compute, and then you are basically shown with all this configuration that you need for this. So when you want to create a cluster, you definitely you can define, you have an option to define access mode. You can option, you have a Databricks runtime. So Databricks gives all set of software in and combine them with a runtime. You, for example, if you're selecting a Databricks runtime, the latest version like 13.3 or any latest version, you'll get like what is Scala you're getting behind the scene, what is Spark you're getting. So based on your workload, you can define your Databricks runtime. There are like runtime for machine learning workload, there are runtime for different kind of workload, and accordingly you can choose. As we know, like a Spark is a distributed processing where you have a driver, you have worker node, so you can choose like number of worker. You can choose like minimum and maximum worker. You can also enable your auto scaling. So if you're not sure about your workload, you can start with minimum, and then based on the workload, Databricks will take care, and it can go up to 8 based on what workload you're performing. You can also do like terminate with after some minutes of inactivity. You can terminate, you can set up your driver worker, and you get like summary, how many dbus you're charging as per your need. So for example, in this case it is charging 4 to 14 dbu per hour, and your pricing will be depend on how many dbu you are charging. Dbu is nothing but Databricks unit. So in term of Databricks unit, you'll get charged, and accordingly you can set up based on your workload need. So that's how we create a cluster. Now let's talk, and simply like if you go to this Databricks homepage, simply we can go to workspace and we can start creating a notebook, and it's as simple as that. You just write, click and create a new notebook, and you can start writing your Python or Scala or any program that you want to write for your data processing. Let's Now let's go to Databricks architecture. Sorry. So if you see like this is a complex diagram, but we'll try to divide it into pieces, and we'll try to understand. So let's understand how Databricks work behind the scene. So if you see here, there are two part of this architecture. One is Databricks control plane, and one is Databricks data plane. Control plane sits in your Databricks subscription. So when you create a Databricks workspace, as a user, when you create a Databricks workspace, you get Databricks web application, which you basically access with your web UI or your browser. You access your web application. So then you go to control plane. You access this web application. It basically uh, it contain all the configuration for your web application, whatever we have seen in the screen. Like if you are creating a cluster, so all the configuration related to cluster, all the customer notebooks, if you are creating jobs, queries, everything, so everything sits into control plane. And this control plane basically will be as a front end for you, where you can log in and you can see all the features provided by Databricks. Although you'll not be able to, like, other than this, like other than going to browser, you'll not have any option to go to the backend of control plane. It's only managed by Databricks. You have option, like definitely you can manage by REST API, but the control plane is something which managed by Databricks. So all the configuration sits here. Now, in your data engineering project, definitely you're going to work with data. So you're going to process data, you're going to extract, transform, and load the data. So all this data processing happens in data plane. This data plane is basically reside in your customer cloud account, depend on which cloud service provider you're using. If you're using, for example, Azure, then in your Azure subscription, this data plane will reside. Data plane is something, for example, if you are creating a cluster, and cluster is nothing but a virtual machine, so your virtual machine will be created in data plane. All the processing for you, like all the data processing will happen in the data plane. And then you'll get the result back in depend, like if you're performing ad hoc analysis, then you'll get the result back into control plane and you'll be able to see the results. So that's how this architecture work, where you have a clear distinction between control plane and data plane. Who manage this basically, like if you all the everything related to your data processing managed by your in your subscription. So the key takeaway from this architecture is like your data, which is your key component, which is not going outside of your subscription. You are processing everything within data plane, and you're not going any data is not leaving your subscription. Control plane is something which you are working, for example, as a serverless application, where you just going to web UI and performing all of these tasks, but ultimately processing is happening within this data plane here. And the data plane responsibility, like if you are working with any cloud storage, then connecting with this storage, or then taking the data, and everything will happen in your subscription. So you are here, your Databricks user is a data engineer or data scientist. You are going to perform a single sign on based on, like, again, which cloud provider using. If you're using Azure, then it happens by with Entra ID or AD we call. And you log into control plane, you see all the facility provided by control plane. And then if you perform any operation, if you launch any job, initiate any job, all the processing happens in data plane. And that's how this architecture is segregated basically. So that's about Databricks architecture. Now I want to show basically I want to go through Delta Lake, which is a new concept. But before going to Delta Lake, I just want to just a quick introduction how current data lake environment is, and there are some challenges which Delta Lake try to solve. So if you see, like there have been many organizations which they have been working with data lake environment. And data lake was in on premises, like in Hadoop. Now it is in cloud environment, where in AWS it is stored in S3, for example. In Azure you're storing everything in ADLS Gen 2 or blob storage. So your data lake is containing all kind of data. But this data lake was there were some limitation, definitely, because ultimately in data lake you are storing data in Parquet format mainly. But this data lake was not uh, having proper BI support, or because everything is stored in term of file, where you don't have any option to perform asset transaction. You don't have a option to roll back the transaction. You don't have like you can't modify. If you want to implement your GDPR functionality, you can't modify a record. Means there are way, definitely, but these are complex, where you have to rewrite your whole partition and again write it based on if you want to revert some data. Then what many organization have chosen, like they have done some ETL on top of data lakes, and then they have loaded, like based on the reporting need, they have started loading data into a separate data warehouse. In Hadoop it was Hive, and now for example Azure SQL data warehouse, and that kind of thing. And all the BI purpose was solved using this data warehouse. But this architecture was basically like you have multiple places where you're dealing with data, and you don't have a single version of truth where your data reside and all the workloads happening with your data lake. There might be something, if something failed in between, you might have data inconsistency. So there are like many problems in data lake architecture, although like many organizations have been using this architecture and depend on their workload, but still they face all these challenges that we have talked about. And that's where like delta lake comes into picture. So what is delta lake? uh, Delta Lake, in short, we can say it is open source storage framework. It was initially developed by Databricks, but now it is open source. It is source storage framework, which basically provide reliability to your data lake. So reliability in term of like data consistency. So your data is going to store in Parquet only. Like before Delta Lake, also like you're storing the data in Parquet format only, but with Delta Lake also you're going to store data into Parquet format. But along with the Parquet file, you are going to have a transaction log, which basically like it's order set of all the transaction that you perform on your Parquet file. And this transaction log is something where all the magic happens. Basically it gives you the ACID functionality in your data lake. It provide you like metadata handling, like schema evaluation, all of these features, history, versioning, everything feature, all these features available to you with the help of this transaction log. So in term of storage, like you are going to store data in Parquet format only, with some additional transaction log. We'll see this transaction logs and everything in the demo, but that's how your storage structure will change. And this delta lake, on top of it, like you have a delta engine, and on top of it you can create a delta table in your cluster, and then you can work with this storage that you have stored in delta format. So this delta lake basically enable you to build a lake house architecture. And that's again a new terminology, like what is lake house architecture. So as we have talked like, uh, we have data warehouse which is good for BI purpose. It's all the BI reports needs, where you're working with data warehouse, you have a reliability, you can perform asset transactions and everything. And that's how this data warehouse architecture was built. We have seen like data lake architecture, where you are having your basically it's good for, you can say, like machine learning workload, data science workload, but it was not uh, having a good support for your BI kind of workload. So you have like something good here, you have something good here. Lakehouse architecture is something which bring best of data warehouse, best of data lake. So it gives like all the functionality, where this is like beneficial for your data science or machine engineering workload, as well as like you get all the benefit where you can basically directly work with BI workload or all your BI reporting needs. So this lakehouse architecture is something where you don't have to create another layer. You have only single version of truth here. So this is your data lake, for example. You're storing all kind of data, structure, semi structure, or any kind of data in data lake. On top of data lake, you're as per Medellin architecture, you're building like multiple layers, raw, bronze, or like bronze, silver, gold, all this layer you're building. And in this layer, for example, like in silver or in gold layer, you can basically take the data from data lake and build a delta lake on top of it. With the delta lake, you get the single platform where you can basically use this data lake for all of this purpose. And these key features are the main reason behind it, because you are able to perform a transaction. You can simply delete record, update record, you can merge, perform merge operation. With the help of delta lake, you basically get the audit trail of the changes, and we'll see in the demo basically like how you perform audit trail, and all the versioning, data versioning, and time travel, and all the functionality, how you perform with or how you get with the help of delta lake. We'll see all these feature in demo, but the key takeaway from here is like this lakehouse architecture will like allow you to have a single version of truth which you can use for any kind of a workload. And in term of storage, like you're not changing much like you are storing data, you are storing data in Parquet format before Delta Lake also. With the Delta Lake also, you're going to store data in Parquet format with some additional functionality that I'll show you in the demo. Let's start with demo, or we'll see like key features provided by Delta Lake. So this is the Databricks. Like I created a notebook environment. Basically, I have one JSON file here. So this JSON file, like simply it contains, for example, like four records here, which have like ID, first name, last name, and date of birth. I'm just writing percent %fs, which Databricks provide like file system utility, which you can write simply like to see any file. And in your case, your file might be sitting in cloud storage. In case of Azure, for example, in sitting in ADLS, you can. There are definitely way to mount, and you can connect to those file system. But you can simply list down either via percent %fs, or you can do via db util fs. So this is just a file which you have in like a JSON file. What I'm going to do here, uh, first I'm going to create a database, and in the database I'll create a table. So what I'm doing here is like I'm just writing a simple command, create database, demo db. I'm giving the location here, so everything that comes under this database will sit into this location. So this location is something like Databricks refine and demo db. This is the location I'm creating where this database will sit. Now I'm loading this data into a data frame. So I'm just using Spark read API. So what I'm doing like spark.read and loading this JSON file. This is our source JSON file. For this demo purpose, I'm just using infer schema, or you can define your schema definitely. But this is like just loading this data JSON file into data frame. I'm just doing a display. So this is the data sets that we have loaded from JSON to data frame. Now, in the next step, I'll load this data into Delta table, and that's I wanted to highlight here. Like, if you are already working in Data Lake, you must be writing your data in form of a Parquet, for example. So I'm using writer API here, a Spark Write API. So what I'm doing like df.write, and this is the format, and this is the difference. This is the only difference in terms of when you, as a data engineer, like this is the only difference. If you are working with traditional Parquet file, you're just giving format as a Parquet. If you are working with Delta, or you want to work with Delta Lake, then you just give the format as a Delta. With Databricks, this Delta is already provided in form of a Databricks runtime. So this is the default format with the latest version of Databricks. If you are already using latest Databricks runtime version, then you will be getting this Delta format by default. Either you define format or not. If you want to define, definitely you define format Delta. It means you want to store this data set in form of a Delta. And as we talked about, like Delta is again like just a storage framework. This will change how your data is stored into that location. We are for this demo purpose, I'm just loading this data into a table. This tables reside into a demo db, where I'm just creating a people table. So this is the table that I have created, and simply because it is a table we have created, so I can just do select a star from this table. And if you see, all there are 4 records which loaded into this table, but this table has been loaded as a delta table. And now let's see like what exactly is stored into the location. So this is the location which we have given for this database. It means your table has been loaded into this location. So this refine demo db people, and this is the location. If I just list down this location, I have 2 files here. One is like a delta log, which is a folder, and then you have a Parquet file. So in term of storage, when even when you store your data in form of a delta, but you are ultimately you are storing your data as a sname like snappy compressed Parquet file. But the key difference here is like you have additional folder called delta log, and here all the magic happens here, like with all the features that you get with the Delta Lake. Now let's go, because this Parquet is like normal how you load the data, but let's go deeper into this delta log folder. So If I list down this DeltaLog folder, I see there are like many files here. One is .crc, one is .json, and the CRC is again like a checksum file where it contain all the statics information and help you to optimize or keep checksum of your record. But JSON is something where you keep transaction, all the transaction that you perform with this data, and start with zero. So currently we will not perform anything on top of it, like no, not multiple versions, and that's why you see only one JSON. Now let's see what is inside this JSON. So if I just do, for example, head in this JSON file, what I see, like I have a record of the transaction that I have performed for this delta. So because we have just created a table, so it's just a create or replace table, and you have like what operation that you have performed, and with this operation what is the path file that have been added. So this is the file ending with c triple zero snappy.pake, and this is the file when you create your table. This is the file where your data has been stored. So for now, like we just created a table, and now let's see, let's perform some transaction operation. So I'm just, what I'm doing is like I'm just deleting one record from the table where f name equals to Rohit. So I'm just deleting this record. You can do it via SQL, and I just, for demo purpose, I just put this Python code also. Like you can also do it with Python if you are not storing in a table format. You're just storing into a location. So from this location you can just do a delta table, import delta table, load into in delta table, and then you can perform delete operation with this also. But for simplicity, for now I'm just performing a delete operation in this table. It's only deleting one record. So let's perform this delete operation. Now I'm on to update one record. So for update also, like either you can do in SQL or you can do in Python way. So this is just a simple update operation, like I'm just converting one record from lowercase to uppercase, and this is just a simple operation I'm performing. So I have performed two operation. One is delete, one is update. So there should be two more version created for your delta table. And now if you want to see the version, so you just type command like describe history and delta table name, and now you see there are three version for your table. So the first version is version 0 where you just created the table. The second version is version 1 where you deleted one record, and the latest version is version 2 where you have updated the record. So every time when you select this table, this is the latest version. After update, what is the state of this your table, you will get out of it. But the good thing here, or the key benefit here, so for example, like if you just want to select the record from this table, you will get the latest version, which is version 2, because one record has been deleted. For one record the case has been updated, and you are seeing the latest version. But you can do a time travel. uh, you can do a versioning, you can go back to the previous version. So for example, I want to go to previous version is of 0. So this version basically, version is of 0 means 4 records, no delete, no case conversion, and you are getting what was the state of the previous version, or version 0. uh, you can go to previous version in two way basically, or either you mention version as of 0, or you mention like timestamp. If you know the timestamp and you want to revert to the particular timestamp, you can just do a select timestamp as of, and then you will revert to that version based on the timestamp. If you, for example, you deleted the table or you deleted the data and you want to roll back your record, so this is just a delete on. If you want to restore, you can again restore to any of the version. So for example, version 0, if you want to restore, you can restore, and that's how your data will be reverted, or your table will be reverted to version 0. Now let's see like how this is happening behind the scene. So behind the scene, if you see again this same folder, like people folder, uh, initially when we saw, there was only one Parquet file and this delta log folder. But now because we have performed multiple operation, and for every operation, based on like what you're deleting or updating, it is to restoring the data into a different Parquet file. So if you see, like there are three Parquet file. Initially there was one, but with all our operation, this data or recent data or the data after modification has gone to a new Parquet file. if I go back to delta log folder now, so initially when we saw, we had only one JSON, which is 00.json. But after our all the operation like delete, update, restore, after all the operation, you have like multiple JSONs file here. So JSON files here. So every JSON file is basically containing your uh, all the transaction record, and with this help, with the help of this transaction record only, you are able to do all this history versioning and all of this functionality. Let's go into, for example, we already see 00.json, which was having like create or replace table. But we have like for example, if you go to 01.json, and the next operation that we performed is a delete. So this is the operation delete. Delete means we are removing this packet file, and then we are adding one packet file. It means like we are taking the data from the previous packet file, which is like now we call it as an old packet file, and we are adding a new packet file here where you are writing data back after deletion. If you are deleting, for example, one record, then whatever record that's available after delete, you are storing into that packet file. And that's how, like, when you want to go back to any version, depend on this with the help of this JSON file, Delta Lakes give you that facility where you can do a time travel and very smoothly. If, for example, if I want to go to 02.json, this is like containing the operation you performed update. With update, you are having some remove, you have some additional addition, and this is the file that is after update. And that's how you basically get all the operation. And again, for example, for 04.json, what do you have performed? Like, you have performed restore. In the restore, you are having this packet file. And in your case, if you are working with large data set in distributed environment, you will not be having like one packet file per table or per source. You'll be having like your data will be distributed in multiple packet file, and this JSON will keep track of all the transaction within the transaction. It will also keep track of which packet file is latest, which packet file belong to which version. And that's how, if you want to go back to the any version, you can go and you can get all the benefits provided by Delta Lake. uh, yeah, I think that's it for uh, from my side. And let's go back now. Let's move to question and answer. Yeah.
Yeah, thank you, Naveen. Very interesting presentation about Databricks and DeltaLake. Yeah, we have several questions. So, what are disadvantages of DeltaLake, and where I should not use it, or
Yeah,
when I
Mhm.
shouldn't
Yeah,
use it?
yeah. I think in term of uh, disadvantage, like, definitely, if you have a requirement, if you want to build, for example, a single source of truth where you want to perform all of your workload, and you are having some challenges with your data lake environment where you might be having like data silos, you are having data inconsistency. If you are using like multiple places to store data, for example, you're using data lake and you're also using data warehouse for your BI reporting. So in term of that, like, you definitely get the benefit by replacing as a single version. But definitely, like, Delta Lake is a new concept where Lakehouse architecture is like new concept. You get the good support for with the help of Power BI, like you directly get a support of it. But it's like not as compare what we get in data warehouse environment. So in data warehouse, we get obviously like full support where directly you can get the report. Delta Lake is evolving, and right now it's not like you'll have a same level of performance what you get in data warehouse versus what you get in Delta Lake. But definitely it is evolving. So that's only, I think, the difference when you change this architecture. Yeah.
Do you understand correctly that DeltaLake needs more storage space, and so it costs more?
Yes, we can say that Delta Lake will take more space, but there are definitely optimization available in Delta Lake where, if you want to, for example, stop your versioning, so you want to keep the version only, for example, last 3 days or last 2 days or last previous two version, you have the optimized commands there. You can definitely optimize your Delta Lake, and you basically reduce the redundant storage capacity that your data lake is using. So definitely you need more space because you are getting a lot of functionalities with in term of like acid and history versioning and everything, but it's in your control where you can manage what you want to optimize.
So need to use it wisely.
Yeah.
Okay. And do you know if it's possible to experiment with Delta Lake using a community Databricks cluster?
Yes, definitely. So with the community cluster, you can create a delta lake format and you can use it. Yeah, that's possible.
And maybe you can give some advice how to experiment with this Databricks community cluster and don't pay too much because you already shown some configuration of
Yeah.
Databricks cluster. So maybe
Mhm.
some.
Yeah. Yeah, I think the one recommendation definitely, like, because if you are using a community cluster, it means you'll not get charged anything. If you basically, community cluster will provide you a limited number of or limited space where you'll not get much of the configuration. If you are using community cluster or creating a cluster with community edition, you'll get a default cluster with 15 GB memory or something like that. So you'll not have, like, you don't have to worry about charge when you are working with community cluster, based on my experience. But if you are working, for example, with your pay as you go subscription in Azure, for example, if you're using Azure Databricks, then definitely choose wisely that you when you create a cluster, you select like auto termination after some duration. You set up general purpose compute type based on your workload. If, for example, if you're just experimenting and not working in real time project, you select your number of driver, number of workers very low, and you just select like a basic cluster and then you use it. But yeah, definitely for learning purpose, you don't have to worry about when you are working with community cluster.
Yeah, and yeah, one more question that was already discussed on another call, on another talk. Uh, how do you think is it if it's possible to learn Databricks without some uh, practical experience?
uh, I would say no, because with Databricks, definitely you need to practice in whatever language that you are writing, like PySpark or Scala or SQL. I would say, like, even if you're SQL expert, you can learn Databricks, because everything that you can do with PySpark, everything is available. Like, you can do in Spark SQL also. So definitely you need at least one of the language and do practice, and then only you'll be able to explore all the features provided by Databricks.
Yeah, that's a question like mostly, okay, you know language, okay, you know SQL, but for example, you don't have a Databricks cluster where to experiment, or if you do, will it be enough just, I don't know, read maybe book and yeah, just watch
Yeah.
videos, yeah, to become
Yeah.
a Databricks expert.
Yeah, I think, yeah, the basic thing, I think you should start with community edition. You create your personal account in community edition where you get limited space or limited computing power, but that's enough for or enough to start learning Databricks in yeah.
All right. Okay, thank you very much. And I think that concludes our session. So thank you all so much for joining us today. We hope you found this session insightful and inspiring. In the video description below, you will find the link to the talk page where you can provide your feedback for this talk. Give speaker a badge and rate the session if you like it or if you don't like it. Your feedback helps us to improve future events and recognize the hard work of our speakers. Additionally, if you'd like to revisit it, you can download the presentation on the talk page and also watch recording. Check the video description in the link uh, and find the link to the talk page. So thank you very much, Naveen, for coming. We could not do it without you. So thank you all.
Thank you so much, and thanks everyone for joining.
Yeah, bye.
Thank you.